Hello everyone, welcome back to the course. In today's lecture, we'll be learning about closures in JavaScript. Whenever we talk about closures, we always have at least two different functions. One is the inner function and one the outer function. The closure should remember the variables present in the outer function even after the outer function has finished the execution. Let's go ahead with an example. Whenever we are talking about closures, we always have two different functions. So let's create that. Let's add a message variable inside this outer function. And inside this function, I want to log this out. And from the outer function, you want to return this inner function. The way I have defined this function right now is whenever I call this outer function, it will return me the inner function. The outer function itself has a message variable, but after execution of this outer function, will this message variable still be available to the inner function? Because the inner function will be executed at a later point. When I call this outer function, it returns me an inner function. And when I call this returned inner function, does it keep track of this message variable? And indeed it does. Hello from outer. We have called this inner function afterwards. The actual execution of the outer function finished over here. But when we call this inner function after the fact, still we got this message variable intact. It is keeping in track of the variables of the outer functions as well. So closure is basically a function bundled together with the lexical environment, meaning it remembers the variables that were around it when it was defined. Now here's where it gets more practical for you. You can use closures to create private variables or even functions with memory. Here are some of the use cases. One is we can define a private state, also have factory functions, we'll look at it, and then currying functions also, an important use case. Now let's create some private variables for it. So JavaScript in itself does not have any concept of private variables, but we can create certain variables which are private to the function itself and it cannot be accessed after the creation. Let's create a counter, and inside this counter, let's have a count. And we'll return a function which increments the count and logs the count. Again, you see you have an inner function that we are returning and we have an outer function which has certain variables associated with it. This inner function will keep a copy of this outer function's lexical environment. Now let's call this. When you execute this function, you get this whole function in itself. And when we run that counter one, it should log out 1 at the start. And it does. And if I run that again, counter 1, 3 times, it is logging 1, 2, 3. That means this counter 1, which is a function, has this count inside it. And whenever we are calling it, it is updating the local copy that it has. Let's create another count, counter 2. And when I call this counter 2, what do you expect? This counter 2 again calls the outer function. That means it has another copy of that local count variable. and as expected counter2 again updates its own local variables as 1 and 2. That means both of these are different copies of the lexical scope of the counter function. And this is what we mean by private variables. This count in itself cannot be accessed after the creation. After we have created this counter1, we can't access the count variable from anywhere. It is now a private variable. That means unless we manually define ways to interact with the count function, we can't access it. So changing this to, instead of returning a function, we can also return an object. And this object could have multiple different functions in it. So one is this function. Let's have a get count function. We can have a set count function. So now we have manually defined interfaces to interact with the private variable. Unless we define functions in order to interact with this private variable, we can't do it, since after returning it now becomes a closure, and now that is private to the function that has been returned. Now if I want to do the same thing, I create the counter1 with counter. Now instead of saying counter1, we are getting an object over here. So counter1 dot, I need to name it something. Both this and this way are the same way of defining normal functions, although the syntax it is a little different. This is the short form. Now I have to say counter1 dot the name of whatever I want. So update function. Counter1 is now an object. Counter1 dot get count. Counter1 dot update again. So now it has a +1, gets count, should show again. Let's remove this counter2 and we have 1 and 2. Let's use the counter1 dot set count. Now let's set it to 5 and counter1 dot get count. After the closure has been set up, the local variable itself, counter1, is keeping track of all that, and all the functions are working as expected on these. And this is how you can create private variables for your functions or objects. Now let's look at a function factory. So I'll create a function factory. I'll create a new function over here. Name it create multiplier. And we take an input x. The thought behind function factory is when you're creating a function, it returns you another function which can be then later on used. Each time you're creating a function, you are passing some parameters that is private to that function. So in here, let's return a function y, and inside the function it will, let's have a simple return x into y. So whatever x we have passed, would be remembered by this function, and whenever we are passing another value y, it will always multiply with the previous one that we had created. So just for an example, let's have a const multiply by 5. Let's have multiply by 5 is the name of the variable, and I will say create multiplier and then give it 5. The x that I have given will always be 5 for this function, and it returns me a new function that we can see. Now when I say multiply by 5 and give it another value, suppose 7, x being 5 is already present. So now it will only multiply 7 into 5, and we need to log that also. And as you can see, it gives me 35. Similarly, each time I use multiply by 5, the x value will always be 5 for that. If I give it the multiply by 5 parameter of 10, x will always be 5, y becomes 10. Now this should give me 50. So now this is creating a function factory. It is returning a function. It is when we are calling this function, it is returning a function again. And I can also define a different const multiply by 10 and whatever value I pass it, it will remember that value. So I gave this multiply by 10 parameter, an argument of 90. Now it gives me 900. This is another use case known as the function factory. Another very interesting use case is currying, and this is asked in interviews quite often. So currying means the same thing, just multiple times. What we are doing here is returning another function in which one of the parameters we have predefined. Again, if I do the same thing yet again, instead of let's have add 3. So first, when we first call the add 3 function, we give it x and it returns the function y. Then again if we call it, it returns the function z. Now this function itself has access to x, y and z, all 3. So we can do what we want over here, x plus y plus z. Now to call this function is pretty interesting. So let's have a const addition equal to add 3. This will return the first function. So I give the value of x over here. Then again, if I have to call it, I have to do addition and then give it, let's name it x added. Since this x added is also a function, this particular function, I would have to call it again, x y added and then give it, let's have 5 over here, and this again I have to call in order to return x plus y plus z. This final value would be y added and then give it the final value. So 10 plus 5 plus 2. And then let's console.log this out and we get 17. So this is called currying. If we already have all these values together, we can directly say add 3 90 brackets 10 brackets 2. So 90, this will return the y function, this again will return the z function, and this will call the z function. So at the end you would have, this will give you x, y and z, and it gives you 102. So that's what currying is. Again, going on to the revision, closures work in JavaScript because functions are first class citizens. We can return the functions and pass functions as parameters also to another objects. Importantly, in closures, functions have access to their parents' scope. This makes them very powerful to create certain patterns in which we can define a function somewhere and call it later on using the scope of the parent. And honestly, once you start spotting them, you'll see them everywhere in event listeners and set timeouts or even custom hooks. At the end of the day, it's just JavaScript remembering where a function came from and letting it hold the memory. And that's closures for you. Stay curious. Meet you in the next one.